This session is on reversing a number. So if I take a number 123, if you reverse the number, it is going to come as 321. How do we calculate this manually? So if you have listened to the other video where we perform the sum of digits, we are going to do the same steps here. We are going to again break down into steps how to form how to do a reversing of a number when we do it manually, and then we are going to convert that into algorithm. Then from there we are going to create the program. So how do we do this? Like, let's take a bigger number, 78579. If I want to reverse a number, how do I start with? I basically take the last number. First I will be having that last number in my memory. Then I will take the next number. So last number is 9. I'll take 9 in my memory, and then I'll take 7. So when I have 7, what I will do is I will make the last number to move one step ahead and add 7 to it. Then I take 97 is will be in my memory, and then I will take the next number, which is 5, and then I move 97 to one step further, and make the 5 added to it, which will become 975. So that is the way we kind of reverse the number in a manual way. So how in a how do we do this? Basically, let's break down. So let's take the 9, and then my memory is having 0, and we are going to add that 0 plus 9, which is going to make it as 9 here, just like how we do it in the sum of digits program. Now the next step is going to be reducing the number, which is 7857. Now you extract the 7 from it. In sum of digits, we just add 9 plus 7 because we wanted the sum of digits there. Here we don't want sum of digits, but we wanted basically in this step we wanted to move 9 to the 10th position and add 7 to it. So we want to make it as 97 here. So how do we make 97 here? We have it in memory 9 and we have a remainder as 7 here. So how do we make 97? We can just multiply 9 by 10 and then add 7 to it. By that way we will be able to form 97. So that's what we are going to do. Take the memory variable, multiply it by 10 and add the remainder to it, add the extracted digits to it. So it is going to become 97. Now reduce the number to 785, extract the 5 from it. Now do the same process, take the memory variable, you want to move it to one position before, so where we are going to make 997 as 970 and you are going to add 5 to it, so that you make it as 975. So exactly we are going to do that and reduce the number, take the 8 from it, make it to 9750 plus 8, which is going to be 9758, and then reduce the number, take the last number, extract the last digit, and then try to multiply the sum into 10 and then add 7 to it, which will result in 97587, which is the reverse of 78579. And there is no more numbers to reduce, so it is becoming 0. The input number has become 0, so we are going to stop this here. So let's do this in a programmatical way. So we will say n is equal to 123 and sum is equal to 0. That's our initial values. Our input is 123. So what I will finally get is 321. That is what I need. For that I need to first start extracting 3 and followed by 3 will, and then you are going to add to it, which will make it as 32. Then you will add 1 to it, which will make it as 321. So how we are going to do it in programmatic way is, calculating the remainder, which is going to get the 3 here, and then the next step is going to be calculate the sum by multiplying the existing sum with 10 and then adding the remainder to it. So here it is 0 into 10, which is going to be 0, plus 3 will result in 3, and then reduce the number from 123 to 12 by dividing the number by 10. So your n will become 12. This is your first iteration. The second iteration, what is going to happen is the 12 is going to be taken and then 2 will be extracted as the remainder, and now 2 will not be directly added to 3. The 3 is the sum variable what you have. You will be multiplying the 3 by 10, which it makes it 30, and then you are going to add remainder 2 to it, which is going to be 32. So your sum will be 32 in this step, and then n will become 1 from 12. Now you do this step again, calculate the remainder. Now it will be 1 and sum is equal to sum into 10. What is current sum is 32. 32 into 10 is 320. 320 will be added to the remainder 1, which is going to make it 321, and then you reduce your n to 0. So you are going to stop this process here. So you put while n greater than 0, you are going to repeat the steps. Otherwise you are going to stop the steps and you are going to get the print the returned, reverse the number. So there's one application to this program. So there's something called palindrome. So if you palindrome is nothing but if you reverse the number, you should get the same number. If you reverse 123, you are going to get 321. 123 is not equal to 321, so it is not a palindrome. But take this number 12321. If you reverse the number, you are going to get the same number 12321. So it is a palindrome. So I wanted to find out whether a given input number is a palindrome or not. How do we do that? We can utilize the reverse program, whatever we have done before. So this is our reverse program where we take the sum is equal to 0 and do the steps. I mean, there's one logic mistake here. It should be sum is equal to sum into 10 plus rem. It's showing the sum of digits, but it has to be multiplied by 10 here. So we take the reverse program and we need to call that program from the main method. So this is my input 123. I'm passing to the reverse number, and the expectation is it is going to give me 321. And once it gives me 321, I'm going to compare the input number with the reverse number. So if the input number is equal to reverse number, then I'm going to print it as a palindrome. Otherwise, it is not a palindrome. Let's do this in the Eclipse. So as usual, I'm going to use the util class. I'm going to create a reverse function which gets the input number and returns the reverse of that actually. So same logic. I think I can copy it from the sum of digits. There is only one change to it. This is the same logic here. So sum is equal to 0, and while n greater than 0, we are doing rem is equal to n percentage 10. The only change will be here. Sum is equal to sum into 10 plus rem actually. So that's the only change here. And n is equal to n by 10, return sum. So this is going to reverse the number. I'm going to save this and call this program from a class. So I can say create a class, new class, name it as the reverse test, or you can name it as a palindrome if you want to test for that. So I can say sysout so reverse is present in util, so I have to mention the class name dot reverse, and I'm going to pass 123 here. Save this and I'm going to run this. So it's giving me 321. Okay, so next thing is I can check for a palindrome. So I can take a number integer n is equal to 12321 and pass this number to the reverse function. So what is the reverse of this number is going to be util dot reverse of n. So I'm going to get some reversed number here. Now I'm going to compare if the reverse number is equal to the original passed number. So I'm going to check n is equal to reverse. If they are equal, I'm going to print it as a palindrome. They are equal. If it is not equal, I'm going to say that is not a palindrome. Not a palindrome. Okay, so let's try to execute this program. So this is a palindrome because as you see it can be the reverse number is equal to the actual number. Let's change this to a different number. Now it should print as this is not a palindrome.